Hey guys, welcome back to this new series on AI, ML, and the exciting world of large language models, LLMs. In this series, we will focus on how we as a developer can easily integrate and consume existing AI solutions, mainly focusing on LLMs. So we will start with the basics, like the basic definitions, difference between the AI and the traditional programming, models, how they learn, and so on. And then we will move on to practical ways of utilizing the pre-trained models in your own applications. So stick around and let's get started. We'll stick to tradition and start from the scratch. So first we will cover some of the basic definitions. Let's start with AI. Here's a very basic definition of AI, that it is a field which is focused on creating smarter machines, machines which can perform tasks which typically require human intelligence. So same as other fields like security, networking, cloud computing, AI is also a field of study. Now the focus of AI is about creating machines that can learn from the data and that can make decisions like humans do. All right. So they can perform tasks like problem solving, reasoning, understanding human language, recognizing images, so on and so forth. Now, how do they do it? How do they learn? And that takes us to the next topic, which is machine learning, ML. Now, as you can see, machine learning is a subset of AI. It is a part of AI, and it allows computers or systems to learn patterns from data rather than being explicitly programmed. So we will discuss the differences between the traditional programming, because this phrase being explicitly programmed is an important one. With the help of machine learning, AI systems learn to find the patterns and examples so that they can perform all those tasks which we discussed on the previous slide. So for instance, if you feed a system hundreds of cat images or dog images, the system can learn to recognize cats versus dogs based on the patterns that it learned from the data. We did not explicitly program the system to just identify the cats and dogs. The system is learning from the data. So this is machine learning. The next thing is deep learning. Here you can see two definitions, one from Google and the second one from IBM. And both of them say that it is a type of machine learning. Deep learning is actually a subset of machine learning. Just as machine learning lies within the space of AI, in the same way deep learning lies within the space of machine learning. Now deep learning tries to follow the model of a human brain. It uses artificial neural networks to learn from the data. And these neural networks could be multi-layered. And that is why it is called deep neural networks. Okay, so these deep neural networks help the systems to simulate the complex decision-making power of the human brain. So just like a human brain would have the neurons, and all these neurons work together, and that is how we learn and solve different problems. In the same way, deep learning is like a simplified version of human brain which is available to the systems, to the computers. And these computers now have digital neurons with the help of deep learning. In fact, the deep in deep learning refers to lots of these layers of digital neurons. Hence, you can see in the definition, it uses the term multi-layered neural networks. That is why it is called deep neural networks. And the advances in deep learning space have allowed the systems or computers to learn complex patterns all by themselves over a period of time. And the last definition that we will cover is NLP, which is natural language processing. NLP lies under the space of AI. It uses machine learning and it enables the systems to understand and communicate with human language. It allows computers to understand and work with human language. We all have used LLMs like chatgpt or Cloud or Google Gemini. And when we interact with all these systems, we are actually using human language. We enter a prompt using human language. They understand that prompt and they do what we tell them to do. So this is all the power of NLP, natural language processing. And here on this slide, you can see how different pieces fit together that we have just described. So AI is the broader space, and under AI, we have machine learning. Under machine learning, we have deep learning. In the same way, NLP is a subset of AI. It has an overlap with deep learning and machine learning. All right, let's move on and try to understand how this AI and ML is different from traditional programming. So in traditional programming, we tell the computer exactly what to do. Okay, so we write the program with all the steps and we tell the runner what exactly needs to be done and how. While the overall AI space focuses on letting the computer learn from data and experiences so that the systems can make the decisions on their own. For instance, we are writing a program for a calculator. So in that program, we know we will handle the inputs, we will take the operator, the operand, and depending on the operator, we will do operations. We will write that code, return a plus b, return a minus b, that stuff. We are telling what exactly needs to be done and how. But imagine we have to write a program or a system that can identify the objects in an image. Can we do that using traditional programming? How difficult or easy will it be? Imagine covering all the scenarios that can occur while reading the image. There could be n number of objects. How do you write the logic? How do you write all the if cases? And even if we are able to write such a system using traditional programming, what happens when there is a new format of the image or new object in that image? So you see, this is kind of difficult using traditional programming, but using AI and ML, we can write a system that can identify objects from the images. If we feed such a system, as we discussed earlier, hundreds of images of cats and dogs, this system can learn from the data and can make a guess by reading an image whether the object is a cat or dog. So that is the difference between AI, ML and traditional programming. By now we understand some of the basic terms and definitions, so we will shift the gear and we will now understand what is a model. A model in machine learning is essentially a function, a mathematical function that transforms an input into an output. So you can see on the slide we have this model which represents a function. Input goes in and the output comes out. As simple as that. On a very high level, you can consider it as a simple function. Alright. Now few terms we need to understand related to model. Number one, parameters, and number two, inference. What are parameters of a model? Just like we have methods in a traditional programming language, and the parameters that we define change the behavior of the method. In the same way, a machine learning model also has parameters. A model can have billions of parameters. And these parameters are just like internal knobs that a model can adjust to improve the accuracy of output. Now, when a model is trained, we will cover training part a bit later, but when a model is trained, after the training, when we use the model to generate or predict the output, this process is called inference. Now, a model can be a very small one. For example, if I write a model that can predict the house prices based on the square foot, then it is a small model. It is a very simple model. It can also be a complex model based on transformers like GPT. We will cover a little bit about transformers when we move on with the course. But a model can be a simple model or a complex one, depending on the complexity or the scale of the model. Now that we understand a model is a function that essentially transforms an input into an output. So how does a model learn? How does it know how to map the inputs to outputs? So a model learns with the help of data and machine learning algorithms. In order to train a machine learning model, we need data, lots of data, and we need a machine learning algorithm. It could be a deep learning algorithm or a different machine learning algorithm, but we need data and we need machine learning algorithm. So when we have the data, lots of data, and when we apply a machine learning algorithm on that data, and when we train the function with the machine learning algorithm and that data, then after the training, what we get is a trained function, which is the model itself. So the machine learning algorithm is the process used to train the model with the help of data, while the model itself is the outcome, a trained function. Alright, a function that has learned to map the inputs to outputs. So in a nutshell, we can say that the model is the trained function resulting from applying an algorithm to data. As you can see on the slide, we have the data, we have the ML algorithm, and we have the function. And after the training, what we get is a trained function, which is the model that now knows how to map an input to an output. On the last slide, we covered that we need data, lots of data to train the model. And out of that data set, we create something called training data sets. All right. So we have three kind of sets: training set, validation set, and test set that we create out of the data set that we have. All right. Now, what is this training set? So the complete data that we have, training set is actually a subset of that data that is used to train the model. In the training process, the model uses this training set to understand or to capture the underlying patterns out of this training set. So suppose if we have the whole data set which has 100 rows, then we can like split the data set into three parts: training set which might have, let's say, 40 records, validation set with 20 records, and test set with 40 records, the remaining 40 records. So that is how we split the data into three sets. there are different utilities provided that we can use to basically create the training set and the test set that we will cover shortly. So the training set is basically a subset of the data that is used to train the model. All right. Now, what is validation set? Validation set is also a separate subset of the same data set, but it is used in the training process to evaluate the model's performance. It provides an estimate how well the model is generalizing to the new data. Because it was trained on the training set, it does not know anything about the validation set. So we test the model's performance using the validation set. It tells us how the model is like behaving to the unseen data. The last one is test set. It is an independent subset of the data, but this is only used after the model has completely trained and tuned. It is used after the training. It is used to evaluate the model's final performance on unseen data. All right, it tells how the model would perform in real world applications. So we have three sets: training set, validation set, and test set, which are basically created from the overall data that we have. Now that we understand the training set, let's understand what is this labeled and unlabeled data. So suppose we are building a system to classify weather as hot or cold based on the temperature. Then the data set or the training data set that we might use might look something like this. Here in the first column, we have the exact values 85, 45. And the second column is like a hint to the model that this should be considered as hot, the first row, and the second row should be considered as cold. So here the exact outcome that we expect is labeled, and this kind of data set is called labeled data because here we have defined the labels, so the model can learn depending on the features, in this case the temperature, what is the expected value for that temperature. So it is hot for the first row, and for the second row it is cold. And in case of unlabeled data, we only have the features. So there is no label, and that you can see in the second table, we only have one column which is temperature. There is no label whether it is hot or cold. This is something the model has to determine on its own. So this is labeled and unlabeled data. Next, we will understand different learning methods. Now there are many more categories, but here we will briefly cover these three: supervised, unsupervised, and reinforcement learning. So in supervised learning, the model learns from the labeled data. We saw an example of the label data on the previous slide. So this is an example of the label data where we have the features and the expected label. So in supervised learning, the model learns from such data types because it can easily understand the expected outcome for a data set like spam or not spam, hot or cold, something like this. In case of unsupervised learning, the model learns from the unlabeled data. Okay, so it learns the patterns from the unlabeled data, like grouping similar words together, for example. So this is an example of unsupervised learning. In unsupervised learning, we have the training data set, but it is not labeled. And talking about the last point, which is reinforcement learning, in this kind of learning, the model learns by receiving rewards or penalties. So for instance, during the training phase, if the model does what is expected, we give it some awards, maybe a point, and that's how model learns that this is the good outcome. But in case it does not do the expected thing, we may cut the points. There could be some penalties defined. So that's how the model learns what is good and what is not good. So this is reinforcement learning. So before we wrap up on this slide, we will briefly cover some touch points. The purpose of this slide is to give you some clarity of thoughts, especially people who are new to this area. And please mind, this is not an exhaustive list. So suppose you are working on some POC related to machine learning, then that's how you typically proceed. You define the use case, you collect the data. And to collect the data and to clean and prepare the data, we generally use things like pandas or numpy or scikit-learn in Python. Once you have the data, once you have finalized the model or the algorithm, you need to split the data as we discussed, because there are three sets: training, validation, and test set. We use scikit-learn, we can use scikit-learn to do that job. The next step is choose or design a model. So we can choose a pre-existing model or we can design a model from scratch. So there are things available in Python that we can use like scikit-learn, TensorFlow, PyTorch for deep learning. Then we train the model using scikit-learn, TensorFlow or Keras. Similarly, to evaluate the model, again, there are utilities like scikit-learn that you can also use to tune and test the model, and you finally deploy the model. So you can see different libraries available in Python and how they fit in a machine learning use case. Now, in this series, we will probably not cover all these things because these are used to generally build something from scratch. But in this series, we will cover the consumption part. Okay, so we will see how it goes as we progress with the series. So here we will wrap up the first video. In this quick introduction, we cover different things like AI and ML, basic definitions, how it differs from the traditional programming, what is the model, how does it learn, different learning methods, and by now you should have a clear sense of how machine learning relies on data to learn patterns. Okay, and in the next video, we will continue this journey. We will cover a few more fundamental topics like tokens, embeddings, and so on. So stay tuned and I will see you in the next video. Thanks for watching.